Okay, so in this video we're going to go through the notes for this page and we're going to work on ionic naming and formulas. From the previous lesson we looked at what ions are and what's the difference between a cation and an anion. And a cation is a positive ion and an anion is a negative ion. So what we're going to do is we're going to look at the periodic table and just kind of review Lewis dot diagrams and the ionic symbols. So I'm just going to open that up. Oops. So on the back side of the periodic table, we've been working with the regular periodic table. Now this is called the periodic table of ions. And what it does is for each element, it tells you the charge that it would take on if it gave or lost electrons. Okay, so the metals, if you remember, so the metals, for example, the Lewis dot diagram for hydrogen would be just one single electron. So what happens is if the metal gives away its electron, guess what happens? Well, it's going to have a positive charge. So you can see that this symbol is the ionic symbol for hydrogen. And you can notice there's one positive charge because it will have one extra proton compared to the electrons. It's lost an electron. And you can see lithium has the same charge because just like hydrogen, lithium has one valence electron. And if it gives it away, then all of a sudden it becomes a positive charge. Same with sodium. Right? Sodium is also a Lewis dot diagram like that. And potassium and so on. And then beryllium, if we think of beryllium, that's the Lewis dot diagram for beryllium. So let's say this metal beryllium has given away 2 electrons to a non-metal. What does the charge on it look like? Well, it's given away its 2 valence electrons, so it has a charge of 2 plus. And magnesium, 2 plus. Calcium, 2 plus. Strontium, 2 plus. Okay, and you can see that those metals, once given away, they have positive charges. Here's a few other ones. We won't worry about the transition metals just yet. That's for another lesson. But if you look at aluminum, right, the Lewis dot diagram for aluminum would, Al, it would have 3 valence electrons. Now let's say it gives away all 3 of its electrons. Right, those have been removed. That means it has a charge of 3 plus. Okay, so let's look over here at some nonmetals, and if we look at, notice hydrogen can also accept an electron. So if you think of hydrogen, it has 1 electron. It would also have room for 1 electron to gain. If hydrogen has gained an electron, it can become a negative ion as well. If it gains an extra electron, then it's negative. Now look at fluorine becomes fluoride, and let's just do that Lewis dot diagram. So fluorine looks like this, and you can see it has space for 1 electron here, and if it gains an electron, okay, if an electron fills that space, then what happens? It becomes a negatively charged atom, 1 negative charge. And chlorine, same thing. Chlorine's Lewis dot diagram. Sorry, that's kind of messy. Looks like this. And again, it has 1 spot open to put an electron in there, and if it does, then it has that -1 charge. Okay, and you can see that all these are the same, -1, iodide. Now if we look at oxygen, it becomes oxide when it's charged. And so oxygen, if we look at the Lewis dot diagram for oxygen, it looks like this. That's kind of messy. I just want to fix this top part here a little bit. Okay, and so oxygen has 2 spots open where 2 electrons can fill that valence shell, And if it gains 2 electrons, well, what happens to the charge? It's going to have 2 more electrons than it would have protons. And sulfur becomes sulfide at 2 negative, and you got 2 negative for all of these. Okay. Now nitrogen would have 3 spots open. Let's just do one Lewis dot diagram for nitrogen. So it would look like this. Oops. Okay, so it would look like this. It would have 5 valence electrons, and so it would have 3 open spots. And electrons, right? An electron can fill those spots. It can strip a metal of some electrons, and once that happens, you can see that -3 negative charge. Same with phosphorus, becomes phosphide as an ion, and so you get the idea. Okay, so it's really important to understanding how this periodic table of ions works. And if you know the Lewis dot diagrams, you also know, well, how many electrons does it give if it's a metal, and how many electrons does it take if it's a nonmetal. Okay, so like I mentioned, ionic compounds form from metal and nonmetal. So here's an example. We've got lithium, a lithium atom with 3 electrons, and we've got a fluorine atom with 2, 3, 4, 5, 6, 7, 8, 9 electrons. And so the lithium has 1 electron in its outer valence shell, and the fluoride has 1 spot in it, valence spot open in its valence shell. So what happens is this lithium will actually give away its electron. So now it's not here anymore, where it's going to be on the fluorine atom, and fluorine as an ion becomes, it's called fluoride. Okay, so that's what happens, and then what happens is the lithium becomes a plus charge, and the fluorine becomes a minus charge. Okay, and that's how ionic compounds form between metals and nonmetals. Alright, so a few other things we need to look at before we get into the formulas and naming. The subscript. So the little values written after the symbol, that tells us how many atoms. So F2, this is called the subscript, and it tells us there's 2 fluorine atoms in the molecule. And so that's used for when we work with the formulas to understand, well, how many atoms of each element are present. And so that's called subscript. So let's look at a few characteristics of the ionic compounds. So it always forms between a metal and a nonmetal. It involves the transfer of electrons, and the metal gives the nonmetal the electrons. Some other properties is it conducts electricity well, it's hard and brittle, and it has a high melting point. Alright, so really key thing to understand is they form between metals and nonmetals, and there's a transfer of electrons. So what we're going to look at is we're going to first draw how the elements would combine to get an idea of how they fit together. So like I said, they're kind of like Lego pieces, and you want to figure out, well, how do these pieces fit together? And it has to do with their valence electrons. So we're looking at sodium and chlorine. And so we want to look at a before picture and an after picture. So the before picture, you have sodium with 1 valence electron and chlorine with 1 open spot, 7 valence electrons. So how these two fit together is the sodium and the chlorine gives the chlorine the electron. Remember, sodium is a metal, chlorine is nonmetal. And so after, how we show this is we have Na, and it has a plus charge. And then if there were more than 1 chlorine, we'd write a multiplier, but we don't. So we're going to put Cl. I'll also put the full shell there. You don't always see this, and we'll put the charge on it. Okay, and so we know there's one sodium fits with one chlorine perfectly. So to show one sodium, we don't put a 1 there. Okay, anytime there's a 1, we don't put the 1. We just say sodium, there's 1, and the chlorine comes next. So the metal is always written first in the formula, and then the non-metal is written after in the formula. Okay. Now let's look at a second one. Let's look at aluminum and fluorine. So aluminum has 3 electrons to give away, and fluorine only has 1 spot open per atom. So what happens is if you have a whole bunch of aluminum and fluorine mixed together, they'll combine in certain ratios. And the ratio is going to be 1 aluminum for 3 fluorine, and that's because each of the aluminum's electrons will move to a different fluorine atom. So these fit together. You have aluminum gives 3, fluorine each take 1. So what it looks like after, you have aluminum, and it has a charge of 3+. And there's 3 fluorine, so we'll put a multiplier of 3, and it's has a full valence shell. Okay, and each one of those fluorine has a -1. Okay, so to write it out as a formula, what we do is metal first, aluminum. How many are there? Just 1. Fluorine, there's 3 of them. So we're going to put F3. Okay, and there's the formula for aluminum and fluorine. All right. So that's drawing it out to see how they fit together. Now we're going to look at, you don't want to always have to draw it out. So you want to have some processes for writing a name into a formula or a formula into a name. So the steps, first we write out the ionic symbol. Okay, so let's look at sodium phosphide. Let's do one more example for that. So write out the ionic symbols. So we have sodium and phosphide. What we're going to do is we're going to use that periodic table. If you haven't memorized all of these ions, which it takes a while to figure them all out, we go to here and we look for sodium. So sodium, just going to change, is right here. So that's +1, and then phosphide is 3 negative. Okay, so that's what we're going to use here. So that's writing out the ionic symbols. Alright, so sodium was +1 and phosphide was 3 minus. So we just determine the subscripts based on the charges. Now the net charge has to be 0 when you add up the charges. So if we just had 1 sodium and 1 phosphorus phosphide ion, you'd have +1 and 3 minus. They don't add up to 0. So you're always going to get a net charge of 0. So one way to think of it is, okay, so phosphorus, we have a charge, we have 3 minus here. So right now there's a charge of 3 minus. So how many sodiums do we need to match up and to cancel that out? Well, we have 3 positive charges. We need 3 sodium ions. So it's going to look like this. We need 3 sodium, Na3, metal first, non-metal second, and then phosphorus we only need 1. So you can kind of think of it that way, and there's actually a shortcut. You can take the charge and you can put it as a subscript for the other atom, and that's called the crisscross method. Now there's no 1 here because we don't show 1s, but there is 1 phosphorus atom there. Okay, reduce the subscripts if necessary. Now in sodium phosphide, you don't need to reduce subscripts because they're in the lowest form. It's like fractions. 2 over 4 you reduce to 1/2. Let's say we have, I'm just going to write one out that comes up sometimes, magnesium and oxygen, so if you figured out the charges of both of those, Mg is 2 plus and O is 2 minus. So if you flip those, did the crisscross method, what you'd have to do is reduce that to Mg1, but we don't write the 1, and O1, we don't write the 1. Okay, so that's reducing these to the lowest form. Alright, so let's quickly do one more example. Magnesium bromide. Okay, so we're going to look at that periodic table for our magnesium and bromine, the bromide. So let's find those. Alright, so magnesium, there it is. Once you use it a bunch, you kind of get familiar with it and you can find them quite easily. And then bromine becomes bromide, and that's 1 minus. So let's go back and, so magnesium is 2 plus, bromine is a minus. So we write those symbols out, and the 2 goes here, and 1 on the magnesium. Now if you wanted to look at the charges, you say, okay, well, magnesium is 2 plus. So how many bromines do we need to cancel that out, balance it out? We need 2 of them, right? If we're adding them up, that would give us 2 plus and 2 minus. Okay, so now what we're going to do is we're going to write the formula, or sorry, the name given the formula. And what we do is we write the metal first. Okay, so we write calcium and chlorine. Okay, so we write the metal first, calcium, and then we write the, actually probably shouldn't have written, let's leave this off for now, okay, just for the steps. So we write the non-metal second, okay, so the non-metal second, so we're going to write calcium and chlorine, and then we change the non-metal ending to IDE. Okay, so we write calcium. We're going to keep the root of the word, so the chlor we're going to keep, and you do that for each of them when you're working with them. And then we're going to change that ending to IDE. Okay, and there's that ionic name. And now let's look at one more example. So we have aluminum. Write that first, and then we write not bromine, but we're going to write bromide. Okay, so we've changed that INE, right? It was this before. I don't usually write it out twice. We change this to IDE. And if you're not sure about those, you can look at the ionic periodic table of ions. And I mean, if you zoom in, sorry, I'm just going to erase some of this mess. You can see the IDE has been added to this, the end of the has been changed on here. So if you're not sure, you know, it's oxide, fluoride, chloride, bromide, selenide, arsenide, nitride, etc. So you can read it and write it right from this periodic table if you need to. Okay, so there's some reading to do after this, some more details, some reading, and I'll talk to you later at the end of this lesson.